Hi, this is Nick Earl, CEO of Eseye, and welcome to the IoT Leaders podcast. And today we're talking smart buildings. We're talking sensors, massive IoT, the ability to get information from anything at all, anything, and get it through a gateway and consolidate it. And the case studies here from a partner of ours called Haltian in Finland are really impressive. I think we cover four or five case studies where they are implementing massive IoT already, including one case study where they smart enabled a hospital in 7 hours. So quite amazing. It uses a very interesting technology, mesh network called Wirepas. And as I say, uses gateway. And what's also interesting about this one, I really encourage you to stay listening to the end, because the end we talk about the vision of multi-RAT, so multiple radios and satellite, and the importance of the device and how you do long-tail personalization of connectivity by letting the device choose the network. And that's something that Haltian and ourselves at SI really share the vision of, is that ultimately the switch has to be resident within the device. So this is a company that's really doing very well. He announces on the podcast, and I didn't know that they've just won Toyota. They also do the world's largest warehouse company. So they're doing smart buildings right now, and they're scaling very fast globally. So I think you're going to really enjoy this. And so here we go with my chat with Jarno Majava, who runs product for Haltian, IoT company and a partner of ours in Finland. Here we go. So Jarno, welcome to the IoT Leaders podcast.
Thank you, Nick. Happy to be here.
Yeah, I'm really happy you're here as well, because Haltian, and we'll get into this, is a very interesting company using some pretty cutting edge technologies to solve big problems. And we'll talk about them, the industry verticals like smart buildings, healthcare. But you are pretty advanced at the cutting edge. And I know that you've got a vision of where things are going to go, and particularly from a device perspective, which we want to get into as well. So we've got quite a bit to talk about. But before we do that, for the listeners, can you just give me a little bit about your background and why and when you joined Haltian in Finland?
Sure. So, like many of us Finnish engineers, I started my career at Nokia. I spent 11 years in there in various roles, but also including IoT, which is kind of funny. At the time, it was called machine-to-machine communications,
Yeah.
and I was managing that portfolio of products at Nokia. And after that, I joined another Finnish stock-listed company, but I moved to the USA and designed and developed the first satellite terrestrial smartphones. So essentially a Windows mobile smartphone with satellite connectivity.
Oh, that's interesting.
Yeah,
Yeah, that's where we're going to end up with this story. And you actually are saying you started out with that with satellite and mobile phones. Yeah.
Yeah, exactly. I have a few years of satellite technology background as well, and we also had several other customers on those for those products. And then I moved back to Finland and started selling tactical communications and high security products to various governmental customers here in Europe. And I joined Haltian 2 years ago, actually, and I'm heading product management. So I'm responsible of our product portfolio, strategy, and roadmaps.
And a lot of people won't be aware of Haltian. Of course, we are. You're a customer of ours and have been. We're partners, and we have been for quite a while. But maybe just a brief overview of what do Haltian do?
Yeah, Haltian is a smart building company. So we really focus on smart buildings and provide IoT sensors, gateways, services, tools, applications, including digital twins. So it's kind of an end-to-end solutions for smart buildings, and more specifically, we focus on corporate offices, hospitals, and also warehouses and logistics.
And you're not just, I know you're speaking to me from the middle of Finland, as you told me. But actually you're more than a Finnish company, right?
Yeah, we have been expanding internationally. So we have sales offices in 7 countries at the moment, and we have customers in 28 countries. So it's not just a Finnish game.
There we go. All right. Um, so one area I wanted to move into is as I said in the intro, is the technology. And you use very effectively use a pretty simple technology called Wirepas. So
Mm.
that's, people don't know it. It's WIRE, just PAS, which is also a Finnish company. But I was looking at their website, and it really is a cool technology. And let me, you know what? Let me describe what I think it does, and then you can correct me and tell me what it really does. I know you were at a conference, a Wirepas conference recently, so you really will correct me. But in my understanding, Wirepas is a very small, light, relatively cheap sensor that can be attached to pretty much anything, but it
Mm.
works on a mesh network. So you start off with a connectivity hub, for example, and then you put it's really Metcalfe's law applied. You know, it's the power of a network is the number of nodes squared. But it works in a mesh fashion so that you add another sensor, and the sensor says, "Oh, I can see where the gateway is." But
Mm.
that new sensor device number two, or sensor number two, then starts broadcasting. It says,
Mm.
I can see the gateway, I can see the gateway. So then a third sensor, instead of having to connect to the gateway with a hub and spoke model, which gets very complicated,
Mm.
connects to the second sensor and goes
Yeah.
through. But the fourth sensor may say, no, I'm going to go direct to the gateway.
Mm.
And so you rapidly build up a mesh. And then if there's any issues whatsoever, they can actually change their routes, sort of like
Yeah.
the way the packets work on the internet. But the
Yeah.
net effect is you can deploy and scale very, very rapidly and get very high density of sensors
Mm.
in a very small area. All right,
Yeah.
how did I do?
That was a good summary. Thank you, Nick. So well done. Let me just add a couple of things. So it's really a self-forming and self-healing network. So if any of those nodes disappears, the network will pick it up, and it's really a robust way to build IoT solutions in smart buildings. And like you said, it's really scalable, so and ultra high density as well. So you can put 10,000 devices, small sensor tags on a pallet, for example, and you still get the messages through. And
10,000 on a pallet.
yes, yeah, I
Wow,
think
that is
Wirepas
density.
has public demonstration of 6,000 sensors in 1 cubic meter. So and we have exceeded that at Haltian. So it's really powerful.
So that's not only technically pretty cool, but we've been talking, I very much recognize your point when, I first got involved in IoT when it was called M2M. In fact, you could arguably go back, it was factory floor automation and things like that even before that, but let's not go back too much. But we've been talking about IoT, and 50 million things are going to be connected. And then some people say, no, 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 it's going to be 500 billion things. It's going to be a trillion things. And we suddenly realize, well, that's broadly called massive IoT.
Mm.
And, the ability to attach a sensor and have the data transmit reliably to almost anything, any physical thing at all. And the sensor could have its own power source. You can print a battery. It can be tiny and whatever. So we're talking here about the potential for massive IoT, aren't we?
Mm. Yeah.
Um, Very high volumes of data and of devices, small amounts of data being transmitted. But I guess that's why when you say smart buildings, this is very relevant because you want to track everything in a smart building or in a hospital
Yeah.
or that sort of use case, right?
Yeah, exactly. And it's not only tracking, it's all kind of a smart sensoring. So whether it's measuring the temperature or utilization of the building, like people counting or utilization of the meeting rooms, it can be reading the electricity meter. So it's not only tracking, it's all kind of IoT sensoring, which can be made more scalable and robust through this mesh network.
So let's very exciting, and we've been talking about it for a long, long time. We're going to get, of course, into the, as we always do on these podcasts, into the practical details of implementing IoT. But for the moment, can you bring it to life with maybe a case study of an example where you have used it and put it inside, let's say, a building, a smart building, or something like that?
Yeah. And do you mean Wirepas in general or
I don't mind. I know you've got a great. Were telling me about a great story about New York. So I don't mind you choose the example just to bring it real, because a lot of people have been talking about this, and we've been to lots of conferences on smart buildings, smart communities, smart cities,
Yeah.
and
Yeah.
we're still not really there unless you have the ability to start from scratch and build
Right.
a complete new location, which most people don't. But
Yeah.
yeah, maybe just a building example.
Yeah. Yeah. Maybe I can give two. So
Okay.
let's maybe start by start with a story of the biggest warehouse operator in the world called Prologis. They have 5,500 warehouses globally, and in those warehouses they have customers like Amazons and DHLs and other major corporations, and they are using our sensors to, for example, preventive maintenance. So they are detecting in the technical rooms of those warehouses if there are any leakages, if the machines are working properly, and so on. And maybe another example from the office corporate office world is that in many big cities we have customers like Ernst & Young, Telefonica, New York Life, and many others who are using our sensors to measure the utilization of those offices and also making sure that the indoor air quality is up to the level that where people feel comfortable, and this is obviously important after the COVID, where people started hybrid working, and companies are often unsure how much space do they need for their employees, and so we really have a lots of different use cases from many different customers. So these are only two, and in the Wirepas open event that you referred to, we actually announced another major customer, which is Toyota, and Toyota is now piloting our solutions in their manufacturing facilities. So it's kind of difficult for me to select only one case, which is showcasing the importance of the Wirepas or Haltian sensors in general, because there are quite many.
Yeah. Now, and absolutely, this is an opportunity to talk about as many customers as possible. Congratulations on the Toyota win. I didn't know that. Obviously, huge potential. The technology, from my understanding, one of the advantages of this solution is that it's very robust, and it sort of works out of the box, and you can implement it pretty quickly. I think you were telling me about a customer in New York, Manhattan, where you were asked to do something and something to do with the chairman's phone
Yeah.
or whatever, which I thought was a good story. Maybe you want to repeat that one.
Yeah, it was really a well. Of course, it's not funny when the chairman is calling that my phone is not working, but it's kind of funny because we had our sensors and gateways in that building for, I don't know, 2 years, and suddenly there was a problem that the phones didn't work in the chairman's office, and at the moment, the assumption from the customer was that this may be due to the interference that is caused by the Haltian gateways, which are
they blamed you, basically.
Yeah, exactly. And in those gateways, we obviously have the SIM cards from Eseye, and this.
But they blamed us.
Yeah, and this
there's really... a phrase which something rolls downwards. I'll use stuff rolls downwards, but it's another word, not stuff. Yeah. But yes. We often recognize that situation, Jarno.
Yeah,
it's the SIM card. Yeah.
Yes, and it was really showing the power and the benefits of our partnership. So together with Eseye, we were quickly able to show that actually this is not the problem. This is not causing the interference. These are the frequencies where we are operating. And just to make sure, we localize the SIM card to just select that one specific US carrier, so that we could also to make it bulletproof, that there wouldn't be interference. And actually, the culprit of this, or the root cause of this interference, was a new installation of the internal 5G base stations that the customer had put there for their kind of to make sure that their phones work inside the building, and that was causing the interference, and that was the kind of the root cause of that problem. But in any case, it was really great that we were able to very quickly show that actually there's nothing wrong with the gateway. If you still want further proof, you just disconnect, and you can see that your problem will continue after that. So it was really a good way to
often
show the customer that our solution is working and it's not causing issues.
Yeah, and I've got a support background, and you often actually find out a lot more about how people are using the technology when you do have support issues, and very often where the finger is first pointed is not actually the problem, but they're very hard to diagnose. Yes. So we're going to get into hardware because a lot of this is to do with hardware expertise, but for the moment, let's just park that. And you mentioned multi-IMSI and being able to switch networks, which gives me, the opportunity to say, we are partners. And we have a great partnership together. But why did you choose Eseye? There's a lot of great telecom companies, there's a lot of great MVNOs. So why did you choose Eseye, and what are the advantages from your perspective?
Yeah, so many of, if not most of our customers are multinational and global companies, and it was really important for us to have a global connectivity, which comes from a single vendor, and it's then easy to partner and easy to scale and easy to add more sites, locations, countries as we grow together with our customers. So that was really one of the key reasons why we selected Eseye, and like you said, it's been a good partnership, and we are happy to continue to grow that in the next years.
And we obviously know the answer, but I think this is our 46th, 47th podcast, and I asked the same question. I think I asked the same question on most of them. Not all have been Eseye customers, but everybody basically says the same thing, which is, paraphrasing it, if you need a single product SKU for your own product, which you're selling to somebody else, and you want to be able to deploy it anywhere in the world and get as near as possible 100% connectivity, and we average 99.5% globally. We got customers in I think it's 190 countries. I think there's only 3 that we don't, and the 3 countries that we aren't allowed to go into. But
it's just like there's a room to grow also for Haltian, because we are now.
Yeah, you follow us. Yeah. Well, that's a conversation for another time. But the point is that the often people say, oh, well, the cost of the solution is X. I'm going to evaluate based on the cost of the solution, and that's the right thing. But if you actually look at the back-end business process costs of the costs of manufacturing, the costs, and if you have to insert different SIMs for different countries, the cost that you incur in supply chain, installation, warranty, all your internal processes dwarfs by probably 100 the cost of the solution. And so you're another example of a company that says, look, I can deploy anywhere in the world, and where there is a signal, and we'll get back onto multi-rad, but wherever the signal, I will deploy, and it's a managed service, and it just works, which is kind of the promise that you're making to your customers. We can deploy, and it works. You told me when we did the prep, which was a while ago, because we've had a little delay in recording this one, but you also told me, I think it was I may have got this wrong, it was a hospital use case, and how quickly you can actually implement. And before you maybe recap that case study, one of the things about IoT, I mean, we've got about 800, 900 customers, but one of the things clearly about IoT is that projects can take a long time to deploy, and for various reasons. There's a lot of complexities. But one thing that stood out to me when I looked at my notes is this, I think it was a hospital case study, and just how quickly you can put this Wirepas gateway network in. Maybe you could just repeat that for the listeners.
Yeah. Yeah, our product strategy is really built around easy delivery, easy installation, easy scalability, and so on. A lot of ease. So in this particular case, we had a customer in Bodø in Norway. It's a 10-story building, and they wanted to have a solution for tracking hospital beds and also wheelchairs and some other items. And our team, two guys went there. They spent 7 hours at the site, and in those 7 hours, they equipped the whole hospital with our Wirepas asset tracking solution, and the data was flowing after 7 hours. So
now we've got to hit pause here, because that's the quickest that I've heard about a lot of use case studies, and I think to understand it, I think it's key to understand this Wirepas sensor, isn't it? Because it's very small, and you're tracking things in a hospital. Like, people lose wheelchairs, they lose keys to cupboards, beds. We need beds. Where are they? And it's a very active process. So tracking things, back to our earlier conversation. So how does that work? Do you take a bunch of Wirepas sensors, and do you just sort of stick them on devices?
Yeah, most often,
and they're active. Is that kind of it?
Yeah, most often there is a two-sided tape, but the key to this quick installation is that it's truly wireless and cableless, and it's not only the sensor that is small and wireless and easy to attach, but it's also the network. The locators are, in our case, they are energy harvesting. So we simply attach them next to the indoor lighting or close to the indoor lighting, and we strip out the kind of activation tape, and they start communicating. So it's really fast and simple installation, not only the tags and the sensors, but also the infrastructure. So it's also cableless and wireless. And the one thing where you need power is then actually the gateway, where you have the Eseye SIM, which is then aggregating all that data and sending that to the cloud.
Right. So you only need power in the gateway. So you're taking the power from the light. What happens if it's dark? Does that mean the sensor can't communicate?
Yeah, well, if it's permanently dark, so we only need like 4 hours a day of the lights to be on. And if there are really dark areas like technical rooms or storage rooms, then we can use a USB to power those locators.
Use USB. Okay. But in general, 4 hours of light, and hospitals are lit all the time. Buildings are often lit all the time, but in general, 4 hours of light means that it's a very small, thin device. You don't have to worry about the battery. You called it energy harvesting. Of course, the gateway is where we are, and we need the battery, and we handle all of the battery management and the aggregation of the data and the uploading it into the cloud and giving 100% connectivity globally. So that's sort of how the architecture works. I want to do one more case study because I just think that Haltian as a company has got lots of case studies. And as I said right at the beginning, I mean, I remember back in my Cisco days, which is going back a while now, we were talking about smart cities and the potential and we're still talking about it, right? I
Mm.
think you are doing a lot of it, building by building, but also customer by customer. And I think you've got a big example of the Finnish post office, which is quite an innovative solution. Maybe you want to describe that as well.
Yeah. Yeah, Post is one of our long-time customers, at least 5 years, I think. And it's really one of the biggest ones in terms of number of sensors. At the moment, we are somewhere at 140,000 active sensors, and the number is growing every month. And where Posti is using our sensors is that we all have habit to purchase things online, and when they are delivered, they usually end up in a smart box or
Right.
group of boxes in a grocery store or nearby location where you can pick them up. And our sensors are actually controlling those boxes. So it's in each and every box there is a Haltian sensor which is integrated into the lock of that box. So that's the use case, and at the moment it's really working well. The number is growing, but we are also looking at more kind of a rare but important use cases, like what happens if there's a child who ends up inside that post delivery box, and we have had a couple of those cases here in Finland.
Really? No, you hear these stories. So
Yes.
you've had a couple of cases with children end up inside posties boxes.
Yeah.
Okay.
Yeah. So what we are discussing is that we would also make a detection if there's a person or some animal or some form of a living thing that happens to go inside the box. Then we are able to detect that. So
Yeah, I'm sure kids think.
luckily that doesn't happen too often.
No, but I'm sure kids would think it's pretty funny to stick a cat in there or something.
Yeah.
Um, but the point again, back to the business process, is the ability to have secure opening and closing notifications to optimize the supply chain of a massively growing area. We had one of our guests on the podcast about 5 podcasts ago was Amazon, which is the first podcast they've done with a vendor, and we do all of the automatic door opening for Amazon Prime, as well as the lockers. By the way, we also do all of the Amazon lockers. Very similar case study. They didn't mention the children, but I'm sure it's happened to them. But the ability to optimize the delivery and the notification of the data. It's really all about the data, is to tell people track your parcel, where it is, has it been collected, have you dropped it off? I mean, it's all about process optimization for them and getting 100% connectivity. It's sort of a long tail personalization, which we're going to go on to talk about because as we mentioned about IoT, IoT is traditionally, it's held great promise, but it's not delivered. Funny enough, today I was just looking at an industry analyst report that came out today, and it talked about the time to revenue for IoT companies has increased from 23 months to 41 months, which is not good, right? If you're an IoT company, but it reflects the difficulties people have implementing IoT. And 41 months to revenue puts huge strain on business models, MVNO business models, for obvious reasons. And you start drilling down as why is the time taken to implement going longer and longer? And there are multiple reasons, but the proprietary silo nature of solutions is a huge factor. And the fact that, an operator typically can give you 80% connectivity, maybe, but not 100. And none of your use cases work on 80% connectivity. MVNOs, multi-IMSI MVNOs can give you maybe 93, 95, and this is industry data, percent global connectivity. But your use cases, 7% loss in connectivity massively affects the promise you give to your users. And then the architecture, we won't go into it now, but the architecture to deliver 100% connectivity is a pretty different, innovative architecture, as innovative as your Wirepas is, because you've got to be able to reroute the connection seamlessly, and it has to be done automated. And that's how we achieve 99.5 globally. But what that says is that actually, right at the beginning of this podcast, we talked about it's not just cellular. And you mentioned satellite.
Yeah.
And not everywhere has a satellite signal. If there is one, we connect. We don't care whose satellite. If there is a cellular signal, we connect. We don't care whose cellular it is. We like to say we don't have a dog in the fight. We're agnostic. But I know that you're wanting to go further and into satellite and what's called the R17 standard, the GSMA R17. And you also you believe that the device hardware has to play a really big role in this. So maybe you can talk about your views of how multiple radio access technologies will play a role in the future, and the role of the device, and how the device has to become much more intelligent.
Yeah. So this is really a good topic, and as we all know, today we have already multi-radios in our hands. We have smartphones that are using multiple technologies, but those are really kind of use case dependent. So they use NFC when they are doing the payments, or they use Bluetooth when connected to your headset. And it's usually the user that is telling the device that, okay, here's the thing I want you to do.
Yep.
And then the device then selects the communication method. But in IoT, there's normally no user to interact with. And the device itself has to be more clever and make those decisions based on what is best available or the best technology at the time. In my Nokia days, that was called least cost routing, so optimizing the connectivity method based on the cost. But I think today it's more about ensuring that there is connectivity, whether you are inside the building, out on the streets, out on the sea, and so forth. And there are, from the device perspective, it's about building multi-radios and supporting multiple connectivity technologies in the gateway, for example, including Release 17 satellite connectivity when we eventually get there. At the moment, we are still in 4G in our devices. But it's also about the kind of standardization, and we talked about Wirepas, for example, and they have seen this as well. It's kind of an extension to the Bluetooth standard if you look at it from the technology perspective, but at the same time they have been now standardizing that, so it's also actually the first 5G non-cellular standard approved by Eseye. So standardization is important, so we get better support from the chipset vendors, and we have more options when we build the products. But then for the device manufacturer like Haltian, then supporting multiple technologies in a clever, intelligent unit is really a way to ensure that connectivity is working everywhere. And then last but not least, obviously, the connectivity provider and how we work with Eseye is then finalizing the package. So
yeah, that's a very good explanation. It gives me option to link to the number one piece of collateral that's downloaded from our website is every year is our predictions report, and we've been talking about multi-RAT and the device's role in selecting the connectivity. And this year's predictions report goes is all about. I think it's themed. It's all about the device, and the point about it is that you mentioned least cost routing, as the Americans call it, least cost routing. And of course, one of the reasons that people do that is that they've done a contract for a fixed price and then they try and optimize their profit by then switching it to networks. But your solution really has to be based on maximum provision of service and quality, resilience, and lowest latency, which is a completely different model. So you have to, and still have to provide it for a fixed price. And in order to do that, and then you could say, well, cellular is only 13% of all connections. I mean, you mentioned Bluetooth, BLE, mesh networks. I mean, Wi-Fi. Cellular is only 13%, and the percentage is getting smaller. And when satellite gets introduced, it will get even smaller again. So our view is that not only does the device need to be intelligent, but actually the switch needs to be resident in the device. Today, the switch is in the cloud. We deliver you 100% connectivity globally because we're using, software, machine learning. We're using a series of things to say which network should this device connect to. Now it's long tail personalization, and you don't see the switches that we're making. You just get connectivity, but switching in the background because we have, so many. We basically connect to any network. When it gets to multi-RAT, then actually it's a little bit more than just the switch, because you not only need to have a path to in this case, the satellites, but you basically got to treat the satellite as if it was just another IMSI. But then you've got to have the intelligence in the device to update the firmware settings so that the modem, or a different modem even, can connect to the satellite rather than connect to cellular. And there's a lot of different firmware settings to make that all to be seamless. So we talked a lot about Smart Connect, which is our offering, which is essentially a device-centric switch, very small footprint, which is programmable by the customer, like yourself. So you can use lightweight M2M in the cloud to set the rules, but then it is deployed and runs on an individual device basis. And essentially, you've turned the model upside down. Now you've got the device making the intelligent switching decision. So the device doesn't have to communicate to the cloud to actually switch. Now, when the device doesn't have to communicate with the cloud, you are then even further optimizing for service provision. But what you're also doing is you're going from connectivity to resiliency, because now you're saying, you talked about self-healing. This is exactly it. It says, look, it's healed itself, and you weren't even aware of it. It's chosen a different network because of the circumstances it finds itself in and what's happening, and then it will also self-heal and change again dynamically. In order to do that self-healing, that we believe firmly, the switch has to be driven from the device out, not from the cloud in, or definitely not from the operator in. But it has to be able to access those other two layers. It has to be able to access the cloud, and it has to access all the operators and satellite networks and all of the other radio access types. So we're basically pursuing the same vision of device-centric switching, which is frankly edge computing. But it's not a model that's common in IoT. It's been very much from the operator out. Which is why, back to that survey, still now in 2024, we're seeing lengthening implementation times, and which is why I wanted to highlight when you said, we put a hospital in 7 hours or whatever. Now it was one use case with putting sensors in and gateways, but even so, we have to, as an industry, solve that problem in order to deliver on the business promise of IoT, and that's exactly the direction you're going in, isn't it? We share that vision of the smart device, because you are device people.
Yeah, we do very much so, and I think they actually pretty much tie together as these multi-radios, context-aware devices where AI can do the decision that should I use this or that connectivity method. And then also the kind of the slowness of implementations in IoT. So I think when we are solving these technical topics together, we are also helping our customers, because they really don't want any silos. They don't want a IoT solution that is solving only one specific problem of their business. Well, obviously, it's good that it does that, but if they have 1,000 problems and you need to build a different IoT solution to solve each of them, you have suddenly 1,000 different IoT solutions in your IT, and that's not really sustainable. So I think we together, Haltian and Eseye, we can also help the customer growth by solving these technical hurdles and building more resilient and flexible products, because then we are also able to have support for multiple use cases from the customer perspective. So I kind of put these two together. So solving technical problems and then solving customer problems, they have the common goal, and that is to have easier, faster, better IoT solutions.
And we couldn't leave it on a better note than that summary. So very exciting going forward. Thanks for the partnership. Congratulations on your Toyota announcement. That's a big one. And very exciting. And you know, in percentage terms, it's got to be at 99 point many nines percentages of buildings that still aren't smart.
Yes.
I mean, the opportunity here is so enormous, and it's not just buildings. We're talking things and trillions of things and massive IoT. So it is very, very exciting, but also challenging, and we have got to solve these problems. So Jarno, I'm going to leave it there. Thanks so much for your time and being on the IoT Leaders podcast, and no doubt we'll talk again soon. But thanks for joining us today, and great podcast.
Thank you, Nick. Thank you.